Hello, let's start with the first real lesson on Python here. Will this first lesson, all these lessons are inspired on this book, Introduction to Python for Science and Engineering. Mostly what I like about this book is that for scientists and engineers, it doesn't introduce more concepts than you need, and the examples are related really to chemistry, physics, and materials. It's a book by David Pine. You can buy it from CRC Press, Series in Computational Physics. Let's start with the basics. The way we are going to do it is we see here the code, we see the result on each cell. This is a Python notebook, and we write the code here on the right to practice. So Python, interactive Python is basically a calculator. It can perform, at least on the most basic level, this is what I mean. It can perform simple arithmetic calculations. Let's see, you go here and you multiply 3 multiplied by 1545, okay? And you have here right away, we just keep practicing here. It's not really deep programming, but it's the basics for us to get used to this setup. We have here the operations giving the expected results. Okay, this one 13, this one 9. So, because here you have the parentheses, and it shows that the order in which arithmetic operations are performed in Python is the same as for most calculators. Let's go for what you expect. These are the symbols for addition and subtraction. Okay, what you would expect. It's really that. And 12, let's do 12 minus 7. Okay, 5. Multiplication, the symbol here, it's the same as you would use, for example, in Excel. Okay, so you should be pretty comfortable with this by now. And the division, also the symbol that you might expect in this type of things. The first different concept that you have is floor division. It's basically the result. It means you divide, and the number of times that you take to divide this, you round the result to the nearest whole number. Okay, this will be 2 point something, and you round to 2. Let's first do this, and then introduce the second different concept that you might be expecting, which is the remainder. The remainder, it's designated by this percentage symbol and gives the remainder after the floor division. So the floor division, the result, it will be 14 from this 7 multiplied by 2, and the remainder will be 1. Okay. Probably will not use this a lot of times, but it's good to know when it appears. Now, something that you might use, it's really the exponentiation. So, 2 exponentiated to 3, it gives 8, okay, and the symbol that you use to be easy for you to code, it's really the 2 asterisks here, okay. Types of numbers. You will be confronted with this on the outputs, it's important, and on the inputs. Integers are the first one. They can be positive or negative. In Python, a number is automatically saved as an integer if it is written without a decimal. This means that 23, written without a decimal point, is an integer. 23 with a decimal point, it's a floating point number. For binary operators, plus, minus, asterisk, which is multiplication, and for division, the output is an integer if inputs are integers, okay? However, the output of the division operator is actually a floating point. If not, it will be the same as the floor division above the result. So you need to have a floating point here. Floating point numbers are essentially rational numbers and can have a fractional part. Okay, this we also need. In this case, you have to obtain a floating point number. Complex numbers, they are what you have learned, also not common to use, but it might be useful for physics, for example, and certain operations. Complex numbers. They are written as a sum of a real and an imaginary part, okay? This will be represented by this, where j represents the square root of -1. What you would expect. Let's write right here to get used to this. And you have the same result. Variables. Now we start with something very important in programming the variables. A variable is a name that is used to store data. The equal sign is the assignment operator. So here, a is the variable, 10 is the number that you assign to variable a. Besides numbers, you can also assign words, okay? And you, for the name, you assign the word John, okay? Let's do it right here, okay? A is 10, name is, let's do it the same way, John. You assign this. You can do multiple assignments at once of several variables at once. For example, C. Okay. And let's see there. If you want to print all your variables, you do this. A, name, C, and D. Okay, 10. And if you print the variable A, name, C, and D, you have what you attributed, 10, John, 5, and 7. Python is case sensitive. It means that variable b, a lowercase letter, is different from variable b, capital letter. You have this right here. Let's show this concept. And b, if you attribute 3, b plus b, you will have the result 5. It is recommended that you give your variables descriptive names, such as, for example, distance, okay, for distance, time traveled, use the underscore, you'll use a lot of times. And if you want to know the velocity, it's equal to distance divided by time traveled. And let's do this right here to practice. Attribute the number to the instance 34. 59, and the velocity time traveled. I didn't give the result. If you want to print the result, you have to print velocity. Okay. Exactly, okay. So, the variable names should immediately remind you of what is being calculated. Okay, if you work with another person, it's very important that they immediately know what is this variable, what it means. This is good practice. But another good practice is to keep the variable names short, so don't be too descriptive. Reserved words in Python. There are some names or words which are reserved by Python for special purposes. For example, import, if, else, while, through, false, and, as, class, is, return, or, not, etc. These must not be used as variable names because they have other functionality in Python, and it's important. Python models and packages. The Python computer language consists of a core language plus a vast collection of supplementary software that is contained in modules or packages, which are collections of modules. Many of these modules, they come with the standard Python distribution when you install. Other modules are not part of core Python and need to be installed and imported. NumPy is a core Python library for numerical computing. It provides fast, efficient operations on large arrays and matrices. NumPy also includes tools for linear algebra, statistics, and random numbers, so you'll use it a lot, or it will be embedded in when you are doing, for example, machine learning. Okay. SciPy is a Python library built for NumPy for scientific and technical computing. It provides advanced functions for optimization, integration, signal processing, and statistics. SciPy is widely used in science, engineering, and data analysis. Matplotlib is the main Python library for creating, for example, visualizations, graphics. It allows you to create plot graphs like line graphs, bar charts, and histograms. It is commonly used for data analysis and scientific research. Pandas is a Python library for data manipulation and analysis. It provides powerful data structures like series and data frames. Pandas makes it easy to clean, analyze, and visualize structured data. Scikit-learn is a Python library for machine learning, the main one. Okay. It provides simple tools for classification, regression, clustering, and model evaluation. Scikit-learn is built on NumPy and SciPy and is very easy to use. These packages, before using them, you have to install them. How to install? For example, NumPy or any other standard package. You install NumPy, for example, in PyCharm using the interface with the PyCharm open. Click here, Python packages, search for NumPy. NumPy, you have right here already installed, but if you want to install, if it was not installed, you click on install and it just installs. So this is one of the reasons I recommend PyCharm because it's very easy to install packages and managing packages. In the terminal, you can also do it. Okay, this will be useful for PyCharm, VS Code, other IDEs. You open a Python terminal, on your IDE and you do like this. Okay, you write Python -m pip install NumPy and you'll run this. Let's not run right now, it's already installed, but you'll just do it like this. The pip is Python's package installer. Okay, it downloads Python libraries and installs them. When you do -pip, it runs the pip that belongs to this specific Python interpreter, this specific Python. If you just run pip Python pip install NumPy, it might install NumPy for a different version of Python in your computer than the one you are using. In Google Colab, NumPy is already installed, but if you need to install NumPy on Colab, just run this command. And if you wanted to install another package, you just change the name of the package here with the package that you want. Remember, files and packages in Colab, they are temporary and reset when the runtime restarts, which means you have to install every time. But if you have this in a cell on Colab, it will install every time you use it, you run it. Importing models and libraries. The models and libraries listed above are not part of core Python. They need to be imported before we can use their functions and data structures. For example, importing NumPy, you're just using import NumPy. And it imports NumPy. You don't see anything, but it's imported now and you can use it. You have now access to its functions. Let's test it. Let's print NumPy sin 0.5 and let's check the result. What you would expect. But there are functions with the same name that can be in more than one package. And by doing this, it guarantees that you are using the same function from the NumPy module. There is, for example, a Python module called math, which also has a sine function, and to use it, you do the same, but for math. Okay. And that's it. Writing NumPy before each function can be a little verbose. It takes work. And to simplify this, you can define an abbreviation. So import NumPy as NP. This is the standard way for NumPy. And it's very good for you to use the standard way because then everybody knows what it means. And then it works the same. Okay. It gives the answer. You can also import a single function from the whole library. This makes it lighter, okay? So from, and it will be from NumPy import just the function log. And if you can also import several functions at once. And that's it. That's the first introduction to the basics of Python here on PyCharm, and it works exactly the same, for example, if you're using Google Colab. Thank you very much, and see you on the next lesson.